Hi everyone, welcome to our video on finding the absolute extrema when we have a polynomial function. So our process is here, written out, okay, so you can kind of see it. We want to find what are called the critical numbers, which is just setting our derivatives equal to 0. And then once we have our critical numbers, we're just going to plug all of those critical numbers that we find into the function, the original function, along with the endpoints. And then we could always check with a graph, a graph of it with a calculator. Okay, so let's see. So it says determine the absolute extreme values of f of x on the given interval. So we see that interval. So I usually like to find the critical numbers first. Okay, so critical numbers, I'm going to label as step 1. Okay, so our critical numbers is, let's find the derivative. So that's our f prime of x. Is, okay, so the power rule tells us 3x squared minus 12x, and then derivative of 4 is 0, so that's it. And then, but typically we look to factor, so when we factor, we'll have f prime of x is, looks like I could take a 3x out, so 3x, and then looks like I'd be left with x minus 4. Okay, so this is the derivative that's been factored. I'm going to do a light cloud around it. All right, but now that we have it, I would want to set the derivative equal to 0. So setting that equal to 0 will give us our critical numbers. And so when we set the derivative equal to 0, especially now that it's factored, we could just set each of these individual factors equal to 0, and then we could solve. So on this first one, all we have to do is divide by 3, and it gives us x is 0. And then on this one, if we add 4 on over, x would equal 4. Okay, so let's box these up. And so I did box them entirely. See if they're in the interval. Notice that 0 and 4 are both in this interval. So that means these are critical numbers. So if one of them was not in that interval, then we would get rid of it because we wouldn't care about it anymore. Okay, but these are the critical numbers. And so now at this point, all we have to do is plug it in. So step 2, we're going to plug in all of the critical numbers, so these two critical numbers, along with the endpoints, all into our original f of x. So let's go ahead and do the endpoints first. So I'm going to do f of negative 2, and we'll get negative 2 cubed minus 6 times negative 2, and then that's squared plus 4. Okay, and then even here we could use a calculator to help us. It looks like it would be, so this is negative 8. So let's see if I could do it without one. So this is negative 8. This would be positive 4 times 6, but it would still be minus, so it would be minus 24, and then plus 4. Okay, so this all equals negative 28. So it looks like we have negative 28 is that. Okay, and I'm just going to cloud it for now. We're going to come back to it. All right, and then now I'm going to do the other endpoint, 10. Let's plug in 10. So f of 10 gives us 10 cubed minus 6 times 10 squared plus 4. And then this looks like it'd be 1,000 minus, this would be 600, and then plus 4. Okay, so 1,000 minus 600 is 400, plus 4 would be 404. And again, I'm just going to kind of cloud it. We're going to save it for later. Okay, so that's our f of 10. And then now let's do our critical numbers. So now let's plug in the 0, so f of 0. When we plug that into our original function, we will have 0 cubed minus 6 times 0 squared plus 4. And then, well, 0 cubed minus 0 would be 0 plus 4 is 4. So again, I'm going to lightly cloud it. And then our last one, 4. X equals 4 goes in. F of 4 gives us 4 cubed minus 6 times 4 squared plus 4. Okay, and then let's evaluate this. So 4 cubed is 64. This is, so 6 times 4 times 4 is 16, so 16 times 6. Ooh, that's a tough one for me mentally. Let me think. Is it 96? So minus 96. We'll check with our calculator. And then plus 4. All right, so when doing this subtraction, it looks like it'd be negative 28. Okay, so we're gonna double check this though right now. So I've got these clouded. We want to figure out which one is the maximum and which one's the minimum, the absolute maximum and the absolute minimum. If I did this math right, it looks like our biggest value is 404. So this is currently our absolute max, because that is the biggest. And then our smallest value, well, the negatives are smaller than positive 4, so these are a tie for our absolute minimum. Again, if I did the math right, we're going to double check right now. Absolute minimum. Okay, so if you have a tie with the smallest y coordinates, then that's okay. They would be both the absolute minimum. All right, well, I said I wanted to check it. Well, that means I'm going to go to my friend here. Let me pull it up real quick. So you know where I'm going if you've been watching my previous videos. I'm going to Desmos. There we go. Let me make it so you can see it. Okay, so there's Desmos, and then I'm going to do the graphing calculator, and then we're going to plug that function in. So I have x cubed minus 6x squared plus 4. Okay, and then let's get to where you can see it all. Okay, so there's where it is. Let's get the projector. Okay, so there's our graph. Let's zoom out a little bit. Okay, so you can kind of see what we've got. And that's just the picture. Notice you do have relative extrema because you do have a peak here and you do have a peak here. So if it wanted relative extrema, we do have those, but our focus is absolute. So now all I'm going to do is just go to the table to really make sure, or actually let me plug in, let me go to the table. Let's go to the table and see. Okay, so I plugged in. So I want to plug in the negative 2 and the positive 10. So let's go ahead and get rid of that and plug it in as 10. And then we also had 0. And then we also had 4. Okay, and then let me get rid of that one. Okay, so there's our four values that we did. And then, so it looks like I did my arithmetic correctly. And then, well, we have it. Okay, so our smallest y coordinates based on the interval that we have are the negative 28s. We did have a tie. Okay, so if there was a smaller one, that is it. Just choose the smaller one. But because it is a tie, that is our absolute minimum. And then 404 is obviously the biggest one. Okay, so let's finalize this. So notice this. The calculator does a great job of finding them. Okay, but still make sure you could use your calculus as well with the derivatives, because it's useful for other things. Okay, so the graphing calculator is a powerful tool though. All right, but let's finalize it. So the absolute extreme values. All right, so let's list our maximum first. So the 404 is the absolute maximum. So we have absolute max is 404 at the x value that we plugged in at x equals 10. And then we have the absolute minimum is the negative 28 at x equals, we did negative 2 and positive 4. So we just list them both out just like that. And there, let me box it up. There's our final answer. So notice again, the absolute max, if all they ask for is the absolute max or the absolute min, it is just this or just this. And those are y values. Those are y values right there. So the absolute max or the absolute min is just the y value. I'm adding the at part because they often say, they ask where does it occur. Okay, so if they ask where, that's the x. If they ask what, that's the y. Okay, but that's that. Okay, so let's put a pause. So there's our polynomial. It's the same process for our other problems. So this was step 3, just looking at the clouded ones and then finalizing it, step 3. And that's all. All right. So thank you for watching. If you have questions, please let me know. Otherwise, I will see you next time.